Alright guys, if you're just joining us, we are messing around with trying to measure and illustrate scroll intolerance. So feel free to watch the last video to get caught up to where we're at now, but until then, let's not waste any time and install this chuck on that spindle. As always, we'll check our spindle. Pretty good. Now we'll check our chuck. You can see we have a high spot and a low spot. So I know what that looks like, by the way. No, I didn't accidentally leave the tool in the chuck. This is the orientation I kind of keep this at when I'm cinching these bolts down anytime I remove this. Now I know pressing against this, applying some torque might screw up the zero we just set. So that's why this is kind of a back and forth. I'm going to recheck this after I tighten these. Alright guys, well, no sense in recording all of that. As you saw, the spindle was pretty well dialed in, but when I just threw this chuck on there, we were about 1.5 thou to 2 thou out around. Not that surprising. Because I have 3 bolts to choose from, I have 3 different orientations I can pick from. I went and tried all 3. Not much changed there. I kind of went back and forth to find the one that had the most adjustability, which I am limited to, not because of the holes. A lot of people talk about elongating the holes to get more adjustment out of this. I should have recorded this earlier. The spindle actually has a step that kind of receives the chuck, so there's really not a whole lot I can do, but I was able to get this dialed in to less than 1 thou out around. We'll very carefully try to turn this so you can see. Alright, so it's always good to check 2 spots. You can see it's about probably 7 to 8 tenths. I really am not going to be able to get it any better than that. Alright guys, now that our chuck is installed and dialed in best we can, let's go ahead and illustrate what I've been talking about in our last video. So go ahead and cut off about a 4.5 inch piece of 1 inch round stock. I've got mine from Tractor Supply. And of course you'll always want to square up your tool post. We'll go ahead and mark about halfway. Go ahead and install it. Alright guys, so you can very clearly see we have our piece in the chuck. We have our dial indicator set up to check the run out. We've got it at 0 in no particular position, and very clearly we can see this piece of cold rolled mild steel is not very round, which is to no surprise. Even when we move it a bit farther down to another spot, you see it's quite out of round. So that's obvious. Don't forget that is of course translating in the chuck as well. So let's go ahead and turn this down until it's nice and even. Go ahead and oil our piece. Alright, we'll do a 5 thou pass. Alright, still got a bit more to go. I'm going to make an attempt at a finishing pass. This might look silly, but because I'm using carbide with some really crap mild steel, This kind of works. I'll show you here in a second. So we did a 2 5,000ths passes. Now we're just going to do a 10,000, or now we're just going to do a 2,000th finish pass. Try to get this as smooth as possible. I'm spinning the lathe as fast as I can because I'm using carbide. It's going at about 1360 according to my little readout here. What's happening is the material's bunching up at the tip, and it's creating, it's probably can't see with the GoPro, but it's not a very smooth finish. But I've learned using a vacuum to pull the shavings away as quick as you can actually helps a lot. So a bit silly looking, but it works. As I said, we've done 2 5,000ths passes. Now we're doing 1 2,000ths finish pass. It's also a lot less cleanup. So guys, now that our dial indicator is back in position, everything, our carriage is fully locked, go ahead and turn this. See, our needle is barely moving. Move it farther down. Even though we didn't have much support on this end, lock the carriage in, it goes right back to 0. And as you can see, that's pretty round. So what we're going to do now, with the camera still rolling, we're going to go ahead and put this perfectly round section in the self-centering chuck. And we're going to turn down the other side. All right. Our piece is out. We're simply going to flip it around. Put the nice round section in the chuck. And I know this sounds silly, but if you buy one of these brand new and you're messing around with it, take this completely apart first and clean it and lubricate it because it feels so much better than it did out of the box. And I mean, I had lubed it from the outside. I even took the jaws out and I just used 20 weight oil. That squeaking and stuff you're hearing is from this big old AC motor. Anyway, so now let's simply go ahead and turn this down. We'll do a 5 thou pass, another 5 thou pass, and we'll do another 2 thou finish pass just for the heck of it. There's no point to set up the dial indicator on this now because we know it's going to be out of round. Even though this section is now perfectly round, this still hasn't been turned down yet, and we proved earlier on how out of round this is from the store. We'll do 2 5,000 passes, and then we'll set up for the finish pass. Go ahead and do our finishing pass. All right, so here we are again. We did a 5,000 pass, a 5,000 pass, and a 2,000 pass. So dial indicator set back up. We go to spin this chuck, and we're relatively on 0. The carriage is locked in. Back on 0. And it's relatively in 0. Moving around a little bit there. So let's do something a little interesting. So we know this part of the workpiece is perfectly round. We know this part of the workpiece is perfectly round. Let's go ahead and mark on this. We'll just put a mark right here, the starting point. So this starting point is on the blue jaw. You can kind of see the blue there. Let's illustrate removing this piece and putting it back in, but let's move its orientation. We'll move this black mark from the blue jaw to the red jaw. Still on 0, that's a good start. Isn't that annoying? Not a full 1,000th, almost. So let's do this. We'll move it down a little bit. A good thou out around. Let's go ahead and move this from the red to the silver. Just lock it in. All right. Ooh, it's getting worse. So let's move this farther down. And you can see we're not even on the 0 now. Almost a full 2 thou out of round on this end. Let's go ahead and move it back. I just like to repeat. Yeah, about a thou, thou and a half, thou and 4 maybe, 4/10. Eyeballing it really. So just for the fun of it, let's rotate our mark back to the blue jaw. Not bad. Go ahead and move it out to the big end. Yeah, drifting. A little worse than it was originally. All right. So why would a workpiece that's been proven perfectly round on both ends dial out of round simply by turning it in place in any direction in our self-centering chuck? Accepting the fact that we're about 5 to 6/10 out of round, measured at the body of the chuck against the spindle, when our workpiece was in the red position alone, we were between 1.5 thou on the near end and a solid 2 thou out of round on the far end. Now, if we were to zoom in 100 times, there's actually a lot of geometry happening here, even aside from the scroll's minor circumferential inconsistency, which was illustrated in the last video. I happen to know this particular carriage, along with the tool post attached to it, has an inboard drift of about 1.5 per inch of travel. So what that's doing is technically tapering our workpiece. Now what happens is when you put the small end of that taper into this chuck, the clamping force, like electricity or water, is going to follow the path of least resistance. It's centering the workpiece as much as it's aiming the workpiece wherever it happens to fall. Combining the natural free play or slack in the jaws themselves with the random change of a trending high or low spot in the scroll against any random jaw at any random position, plus the addition of a Z-axis in the throat of the chuck because of the slight taper on this piece, that would explain the differentiation in the out of round condition between the near end and the far end of the workpiece. So the slack in these jaws is enough for them to splay outwards in conformity to the workpiece. They are becoming displaced within their travel. But at some point, one or more of these jaws reaches its deflection point before the others. And now you have a workpiece that is sort of centered at the muzzle of the chuck, but aimed crooked. Imagine you're aiming a rifle and the rear aperture is square to the target, but the front side post is out in the grass. It's that simple. Now, as I've stated, this isn't the primary objective to illustrate here. We're more interested in the out of roundness potential of simply rotating a workpiece in its work holder. So it's better to reference the differences at that indicated near side versus acknowledging the far side in this particular exercise because of our bullshit. If you've watched one of my previous videos on leveling the bedway, I have since redressed that, and the lathe is now sitting on some steel plates and everything's all sandwiched in, and I had a weekend of a time getting this thing dialed back in. Maybe a video on that in the future. Maybe. Probably not. But luckily, even using Harbor Freight dial indicators, the goal of this exercise was actually to expose and illustrate that type of intolerance in a 3-jaw scroll chuck. Though admittedly it was slight, even in both examples on the bench and in practice, it does exist. But however small, it can still be very annoying. But that's really all I was setting out to do. And I will soon be drilling out this backplate and installing an independently adjustable 4-jaw chuck. But we'll likely use this one from time to time. They are quick and convenient as designed. So I hope you found this video at least somewhat informative in your own metal turning journey with our ever popular hobby level equipment. It's going to be nice there. But anyway, thanks for watching, and I will see you on the next one.